Today's video is going to be on function operations. We're going to start off by reviewing, and function operations is actually nothing new with the operations. We're just looking at it a little bit differently. So we're going to say let f of x be 2x plus 3 and let g of x be x squared plus 5. We've done this in other units where we've taken those two polynomials and we've added them together. The only difference here is instead of me telling you directly take 2x plus 3 and add it to x squared plus 5, this is what we've done in the past. I've given you the two polynomials to add together. Instead, I just gave it names. I said this is 2x plus 3, so I'm telling you take f of x and add it to g of x, and then you have to fill in the appropriate polynomials. So I could give you 10 polynomials and you just have to tell me which ones I'm adding together. Then we go ahead and we add them together. I know I'm combining like terms, so I've got x squared, we've got a 2x, then we've got 3 and 5, that's going to give us 8. Done. I've added my two functions together. Number 2, it's saying take f of x and multiply it by g of x. So I'm taking my f of x, which is 2x plus 3, and I'm going to multiply it by my g of x, which is x squared plus 5. So we distribute. 2x times x is 2x cubed. 2x times 5 is 10x. Go ahead and distribute the 3. 3x squared plus 15. And I'm going to go ahead and rewrite this, why not, in descending order. So 2x cubed plus 3x squared plus 10x plus 15. There weren't any like terms to combine together, but I went ahead and put it in descending order. In standard form, just deleted my x squared there. Now this is the one that's going to be new. This is f of g of x. This is a composition. This is saying take your g of x and you're going to plug that in to your f of x equation. This is going to replace the x in that equation. So I'm going to take the g of x function, here's my g of x function, and I'm going to plug it in for x in the f of x equation. So here's my f of x, here's the x in the f of x. I'm going to take the x out and I'm going to put the g of x into the place of the x. If I have one x, I substitute it one time. If I have 3 x's, I substitute it 3 times. So I'm taking that g of x and I'm going to plug it into the f of x, so that's 2. Now instead of x, it's x squared plus 5 plus 3. Simplify, 2x squared plus 10, and then we've got that plus 3 still. 2x squared plus 13. So number 4, we have f of 2. Notice how we no longer have an x. This is saying plug 2 into the f equation. So I'm just going to write this down here. So we have f of x is equal to 2x plus 3. So I'm going to evaluate f of 2. F of 2 is where we plug a 2 in for x. So that gives us 4 plus 3. So we just found that f of 2 is equal to 7. Awesome. So f of 2 is 7. Well, now I need to plug 7 back into f of x again. So now if I'm going to find f of 7, that becomes 2 times 7 plus 3. So that gives us 14 plus 3. We don't have any variables left because we're multiplying everything out. So we end up with f of 2 is 17. Break it down into 2 steps. Do f of 2 first. Find that value. Whatever value that is, then you plug that value in. Now I could have done f of 2, I could have done f of g of 2. You can have the same function that you're using, you could plug it into different functions, it doesn't matter, but you work from the inside out. What we're going to add on to this is this aspect of domain. We've talked about domain and range before, and some reminders on our domain. Domain is x values. What are the values of x that I can plug in? I have 6x squared. We more think about, is there anything that I can't plug in for x? And the answer is no. I can square any number of x I want, and I'm going to get true values. I can square positives, I can square negatives, I can square decimals, I can square messy fractions. It doesn't matter. So this is going to be all real numbers. We know about rational exponents. This is 5 to the cube root of x. That's an odd root. We know that we don't have restrictions on odd roots. That's not where we have problems. We have problems with even roots. So this one as well is all real numbers. Here comes that even root. The 2 is not part of that exponent. So this is 2 times the 4th root of x. Even roots give us this additional problem that I can't have negatives underneath it, because if I have negatives under an even root, I get imaginary numbers. So I can only include all non-negative numbers. And the way that we write non-negative numbers is we say x has to be greater than or equal to 0. I can still have decimals in crazy numbers, it just can't be negative. So it can be 0 or higher. This is how I write non-negatives. Number 4, here you may be thinking there's no problems, there's no restrictions, but there is. When we have a fraction, the bottom of your fraction cannot be equal to 0. So I ask myself, what value of x would make this 0? And that would be 0, because 3 times 0 would give me 0. So this is all real numbers except x cannot be equal to 0. Same thing for number 5. The whole bottom itself can't be equal to 0. So I want to find out what number would make it 0. In case you don't know how, or if you don't just see it off the top of your head, you can solve your equation. And you see that when x is negative 2, 2 times a negative 2 would make this a negative 4. Negative 4 plus 4 would be 0. So this would be all real numbers except x cannot be equal to a negative 2. So when we're doing these function operations, we have to not only answer it like we did above, but we also have to list the domain of what that answer is going to be. So the domain of your answer consists of the x values that are in the domains of all the functions being added, subtracted, multiplied, or divided, as well as the answer. So this can be the tricky part. We can't just look at what we ended up with. We have to look at the pieces that we started with as well, because if the original piece can't have that number, then it can't exist in the answer either. So we have f of x is equal to 2x to the 1/2, our g of x, our h of x. I like to start with the original pieces and list the domains first. This first one, I have an even root. Because I have an even root, I can't have negatives. You saw above, really we only have restrictions from even roots and fractions. When I look at the next one, this is not an even root. This is an odd root. So this one is all real numbers. This one may trick you, but we have a negative exponent. This really means 6 over x squared. So x cannot be equal to 0. Because if x was a 0, we'd have a 0 on the bottom of our fraction. All right, so back to our function operations. The first part we had nice integer values of our exponents. Now we're moving into our rational exponents. So f of x times g of x. Here's my f of x, here's my g of x. So it's 2x to the 1/2 times 4x to the 2/5. We are multiplying those two pieces together. So we have 2 times 4, that gives me 8. Here we've got those same bases, so we're going to add the exponents, and remember, pull out that calculator or get a common denominator to get 9/10 when you add those two fractions together. When you change this to radical form, because yes, we still have to have that radical form when possible, we have a fractional exponent, so we do have a radical. The 8 is not getting that exponential value, only the x's. So the 8 is on the outside, the 10th root of x to the 9th power. That's our final answer. Now we need to write the domain. I look at my original function of f of x. This said that I cannot have that says I couldn't have negatives. G of x was all real numbers. I look at here. I have an even root again, which means I can't have negatives. When I go to assess my domain, I have to look at the original functions and the answer, and I have to combine all of the restrictions together. In this case, I only had the one restriction and it was the same, and that's that it can't be negatives, so it's greater than or equal to 0. Next one, we have f of x divided by g of x, 2x to the 1/2 divided by 4x to the 2/5. So we're dividing those like bases. 2 over 4, that's just a fraction that reduces down to 1/2. We have 1/2 and 2/5, that same base, which means we're going to subtract the exponents. Who's bigger? The top is bigger, so 1/2 minus 2/5 is going to give us 1/10. So this becomes the 10th root of x all over 2. Okay, domain. Domain, we had our f of x. This means no negatives, all reals. Once again, we have an even root, and that's no negatives. We do have a fraction, but this fraction isn't limited because it's impossible to get a 0 on the bottom of the fraction. There's no x on the bottom. The denominator is 2. There's no way to make that a 0, so we don't have to consider what would make it 0 because it can't be 0. We have the same restrictions again, so domain cannot be negative numbers. Our last one, so our composition of functions. We're taking our f of x and we're going to substitute it into our h of x. So here is our f of x. That's going to be plugged into the h of x for that x value. So I'm taking that whole thing and I'm going to replace the x. So that becomes 6, 2x to the 1/2 power, all raised to the negative 2nd power. So again, this x came out, that replaced where the x was. This gets substituted in. That is to the negative 2nd power. So to take care of the negatives, we move it all to the bottom. Move it and lose it, that becomes a positive 2. 2 squared gives us 4. Power to a power we multiply, which is going to give us just 4x. We simplify that fraction to get 3 over 2x. All right, now to our domain. The f of x. The f of x cannot be negative. The h of x cannot be 0. My fraction here cannot be 0, so x cannot be 0. So if it's not negatives, it has to be greater than or equal to 0, but this restriction says it can't be 0 either. So when I combine all of the restrictions together, it has to be greater than 0, not greater than or equal to 0, because it can't be equal to 0. I have that problem with the fraction. Okay, that is it for our function operations.